simply search bar here.
Essentials. Initializing a Spring project. An overview of the Spring landscape. Although the Greek philosopher Heraclitus wasn't well known as a software developer, he seems to have had a good handle on the subject. He has been quoted as saying, "The only constant is change." That statement captures a foundational truth of software development. The way we develop applications today is different than it was a year ago, 5 years ago, 10 years ago, and certainly 20 years ago, before an initial form of the Spring framework was introduced in Rod Johnson's book, Expert One-on-One J2EE Design and Development. See this link. Back then, the most common types of applications developed were browser-based web applications, backed by relational databases. Although that type of development is still relevant, and Spring is well equipped for those kinds of applications, we're now also interested in developing applications composed of microservices destined for the cloud that persist data in a variety of databases. And a new interest in reactive programming aims to provide greater scalability and improve performance with non-blocking operations. As software development evolved, the Spring framework also changed to address modern development concerns, including microservices and reactive programming. The creators of Spring also set out to simplify its development model by introducing Spring Boot. Whether you're developing a simple database-backed web application or constructing a modern application built around microservices, Spring is the framework that will help you achieve your goals. This chapter is your first step in a journey through modern application development with Spring. Section 1.1. What is Spring? I know you're probably itching to start writing a Spring application, and I assure you that before this chapter ends, you'll have developed a simple one. But first, let me set the stage with a few basic Spring concepts that will help you understand what makes Spring tick. Any non-trivial application comprises many components, each responsible for its own piece of the overall application functionality, coordinating with the other application elements to get the job done. When the application is run, those components somehow need to be created and introduced to each other. At its core, Spring offers a container, often referred to as the Spring application context, that creates and manages application components. These components, or beans, are wired together inside the Spring application context to make a complete application, much like bricks, mortar, timber, nails, plumbing, and wiring are bound together to make a house. The act of wiring beans together is based on a pattern known as dependency injection, DI. Rather than have components create and maintain the life cycle of other beans that they depend on, a dependency-injected application relies on a separate entity, the container, to create and maintain all components and inject those into the beans that need them. This is done typically through constructor arguments or property accessor methods. For example, suppose that among an application's many components, you will address two: an inventory service for fetching inventory levels, and a product service for providing basic product information. The product service depends on the inventory service to be able to provide a complete set of information about products. Figure 1.1 illustrates the relationships between these beans and the Spring application context. On top of its core container, Spring and a full portfolio of related libraries offer a web framework, a variety of data persistence options, a security framework, integration with other systems, runtime monitoring, microservice support, a reactive programming model, and many other features necessary for modern application development. Historically, the way you would guide Spring's application context to wire beans together was with one or more XML files that described the components and their relationship to other components. For example, the following XML code declares two beans, an inventory service bean and a product service bean, and wires the inventory service bean into product service via a constructor argument. In recent versions of Spring, however, a Java-based configuration is more common. The following Java-based configuration class is equivalent to the XML configuration. The @configuration annotation indicates to Spring that this is a configuration class that will provide beans to the Spring application context. The configuration's methods are annotated with @bean, indicating that the objects they return should be added as beans in the application context, where by default their respective bean IDs will be the same as the names of the methods that define them. Java-based configuration offers several benefits over XML-based configuration, including greater type safety and improved refactorability. Even so, explicit configuration with either Java or XML is necessary only if Spring is unable to automatically configure the components. Automatic configuration has its roots in the Spring techniques known as auto-wiring and component scanning. With component scanning, Spring can automatically discover components from an application's class path and create them as beans in the Spring application context. With auto-wiring, Spring automatically injects the components with the other beans that they depend on. More recently, with the introduction of Spring Boot, automatic configuration has gone well beyond component scanning and auto-wiring. Spring Boot is an extension of the Spring framework that offers several productivity enhancements. The most well-known of these enhancements is auto-configuration, where Spring Boot can make reasonable guesses at what components need to be configured and wired together, based on entries in the class path, environment variables, and other factors. I'd like to show you some example code that demonstrates auto-configuration, but I can't. Auto-configuration is much like the wind. You can see the effects of it, but there's no code that I can show you and say, look, here's an example of auto-configuration. Stuff happens, components are enabled, and functionality is provided without writing code. It's this lack of code that's essential to auto-configuration, and what makes it so wonderful. Spring Boot auto-configuration has dramatically reduced the amount of explicit configuration, whether with XML or Java, required to build an application. In fact, by the time you finish the example in this chapter, you'll have a working Spring application that has only a single line of Spring configuration code. Spring Boot enhances Spring development so much that it's hard to imagine developing Spring applications without it. For that reason, this book treats Spring and Spring Boot as if they were one and the same. We'll use Spring Boot as much as possible and explicit configuration only when necessary. And because Spring XML configuration is the old-school way of working with Spring, we'll focus primarily on Spring's Java-based configuration. But enough of this chit-chat, yakety-yak, and flim-flam. This book's title includes the phrase in action, so let's get moving so you can start writing your first application with Spring. Section 1.2 Initializing a Spring Application. Through the course of this book, you'll create Taco Cloud, an online application for ordering the most wonderful food created by man, tacos. Of course, you'll use Spring, Spring Boot, and a variety of related libraries and frameworks to achieve this goal. You'll find several options for initializing a Spring application. Although I could walk you through the steps of manually creating a project directory structure and defining a build specification, that's wasted time better spent writing application code. Therefore, you're going to lean on the Spring initializer to bootstrap your application. The Spring initializer is both a browser-based web application and a REST API, which can produce a skeleton Spring project structure that you can flesh out with whatever functionality you want. Several ways to use Spring initializer follow. From the web application at this link, from the command line using the curl command, from the command line using the Spring Boot command line interface, when creating a new project with Spring Tool Suite, when creating a new project with IntelliJ IDEA, when creating a new project with Apache NetBeans. Rather than spend several pages of this chapter talking about each one of these options, I've collected those details in the appendix. In this chapter, and throughout this book, I'll show you how to create a new project using my favorite option, Spring Initializer support in Spring Tool Suite. As its name suggests, Spring Tool Suite is a fantastic Spring development environment that comes in the form of extensions for Eclipse, Visual Studio Code, or the Thea IDE. You can download ready-to-run binaries of Spring Tool Suite at this link. Spring Tool Suite offers a handy Spring Boot dashboard feature that makes it easy to start, restart, and stop Spring Boot applications from the IDE. If you're not a Spring Tool Suite user, that's fine. We can still be friends. Hop over to the appendix and substitute the initializer option that suits you best for the instructions in the following sections. But know that throughout this book, I may occasionally reference features specific to Spring Tool Suite, such as the Spring Boot dashboard. If you're not using Spring Tool Suite, you'll need to adapt those instructions to fit your IDE. Section 1.2.1 Initializing a Spring project with Spring Tool Suite. To get started with a new Spring project in Spring Tool Suite, go to the File menu and select New, and then select Spring Starter Project. Figure 1.2 shows the menu structure to look for. Once you select Spring Starter Project, a new Project Wizard dialog, Figure 1.3, appears. The first page in the wizard asks you for some general project information, such as the project name, description, and other essential information. If you're familiar with the contents of a Maven pom.xml file, you'll recognize most of the fields as items that end up in a Maven build specification. For the Taco Cloud application, fill in the dialog as shown in Figure 1.3 and then click Next. The next page in the wizard lets you select dependencies to add to your project. See Figure 1.4. Notice that near the top of the dialog, you can select on which version of Spring Boot you want to base your project. This defaults to the most current version available. It's generally a good idea to leave it as is unless you need to target a different version. As for the dependencies themselves, you can either expand the various sections and seek out the desired dependencies manually, or search for them in the search box at the top of the available list. For the Taco Cloud application, you'll start with the dependencies shown in Figure 1.4. At this point, you can click Finish to generate the project and add it to your workspace. But if you're feeling slightly adventurous, click Next one more time to see the final page of the new Starter Project wizard, as shown in Figure 1.5. By default, the new project wizard makes a call to the Spring initializer at this link to generate the project. Generally, there's no need to override this default, which is why you could have clicked Finish on the second page of the wizard. But if for some reason you're hosting your own clone of initializer, perhaps a local copy on your own machine or a customized clone running inside your company firewall, then you'll want to change the base URL field to point to your initializer instance before clicking Finish. After you click Finish, the project is downloaded from the initializer and loaded into your workspace. Wait a few moments for it to load and build, and then you'll be ready to start developing application functionality. But first, let's take a look at what the initializer gave you. Section 1.2.2 Examining the Spring Project Structure. After the project loads in the IDE, expand it to see what it contains. Figure 1.6 shows the expanded Taco Cloud project in Spring Tool Suite. You may recognize this as a typical Maven or Gradle project structure, where application source code is placed under src/main/Java. Test code is placed under src/test/Java, and non-Java resources are placed under src/main/resources. Within that project structure, you'll want to take note of the following items. MVNW and MVNW.cmd. These are Maven wrapper scripts. You can use these scripts to build your project even if you don't have Maven installed on your machine. pom.xml. This is the Maven build specification. We'll look deeper into this in a moment. Taco Cloud Application.java. This is the Spring Boot main class that bootstraps the project. We'll take a closer look at this class in a moment. Application.properties. This file is initially empty, but offers a place where you can specify configuration properties. We'll tinker with this file a little in this chapter, but I'll postpone a detailed explanation of configuration properties to Chapter 6. Static. This folder is where you can place any static content, images, style sheets, JavaScript, and so forth, that you want to serve to the browser. It's initially empty. Templates. This folder is where you'll place template files that will be used to render content to the browser. It's initially empty, but you'll add a time leaf template soon. Taco Cloud Application Tests.java. This is a simple test class that ensures that the Spring application context loads successfully. You'll add more tests to the mix as you develop the application. As the Taco Cloud application grows, You'll fill in this bare-bones project structure with Java code, images, style sheets, tests, and other collateral that will make your project more complete. But in the meantime, let's dig a little deeper into a few of the items that Spring Initializer provided. Exploring the build specification. When you filled out the initializer form, you specified that your project should be built with Maven. Therefore, the Spring Initializer gave you a pom.xml file already populated with the choices you made. The following listing shows the entire pom.xml file provided by the initializer. The first thing to take note of is the parent tag element, and more specifically, its version tag child. This specifies that your project has a Spring Boot starter parent as its parent POM. Among other things, this parent POM provides dependency management for several libraries commonly used in Spring projects. For those libraries covered by the parent POM, you won't have to specify a version because it's inherited from the parent. The version 2.5.6 indicates that you're using Spring Boot 2.5.6, and thus will inherit dependency management as defined by that version of Spring Boot. Among other things, Spring Boot's dependency management for version 2.5.6 specifies that the underlying version of the core Spring framework will be 5.3.12. While we're on the subject of dependencies, note that there are 4 dependencies declared under the Dependencies tag element. The first 3 should look somewhat familiar to you. They correspond directly to the Spring Web, TimeLeaf, and Spring Boot DevTools dependencies that you selected before clicking the Finish button in the Spring Tool Suite New Project Wizard. The other dependency is one that provides a lot of helpful testing capabilities. You didn't have to check a box for it to be included, because the Spring Initializer assumes, hopefully correctly, that you'll be writing tests. You may also notice that all dependencies, except for the DevTools dependency, have the word starter in their artifact ID. Spring Boot starter dependencies are special in that they typically don't have any library code themselves, but instead transitively pull in other libraries. These starter dependencies offer the following primary benefits. Your build file will be significantly smaller and easier to manage because you won't need to declare a dependency on every library you might need. You're able to think of your dependencies in terms of what capabilities they provide, rather than their library names. If you're developing a web application, you'll add the web starter dependency rather than a laundry list of individual libraries that enable you to write a web application. You're freed from the burden of worrying about library versions. You can trust that the versions of the libraries brought in transitively will be compatible for a given version of Spring Boot. You need to worry only about which version of Spring Boot you're using. Finally, the build specification ends with the Spring Boot plugin. This plugin performs a few important functions described next. It provides a Maven goal that enables you to run the application using Maven. It ensures that all dependency libraries are included within the executable jar file and available on the runtime class path. It produces a manifest file in the jar file that denotes the Bootstrap class, Taco Cloud application in your case, as the main class for the executable jar. Speaking of the Bootstrap class, let's open it up and take a closer look. Bootstrapping the application. Because you'll be running the application from an executable jar, it's important to have a main class that will be executed when that jar file is run. You'll also need at least a minimum amount of Spring configuration to bootstrap the application. That's what you'll find in the Taco Cloud application class, shown in the following listing. Although there's little code in Taco Cloud application, what's there packs quite a punch. One of the most powerful lines of code is also one of the shortest. The @Spring Boot application annotation clearly signifies that this is a Spring Boot application. But there's more to @Spring Boot application than meets the eye. @Spring Boot application is a composite annotation that combines the following 3 annotations. @Spring Boot configuration designates this class as a configuration class. Although there's not much configuration in the class yet, you can add Java-based Spring Framework configuration to this class if you need to. This annotation is, in fact, a specialized form of the @configuration annotation. @enable auto-configuration enables Spring Boot automatic configuration. We'll talk more about auto-configuration later. For now, know that this annotation tells Spring Boot to automatically configure any components that it thinks you'll need. @component-scan enables component scanning. This lets you declare other classes with annotations like @component, @controller, and @service to have Spring automatically discover and register them as components in the Spring application context. The other important piece of Taco Cloud application is the main method. This is the method that will be run when the jar file is executed. For the most part, this method is boilerplate code. Every Spring Boot application you write will have a method similar or identical to this one, class name differences notwithstanding. The main method calls a static run method on the Spring application class, which performs the actual bootstrapping of the application, creating the Spring application context. The two parameters passed to the run method are a configuration class and the command line arguments. Although it's not necessary that the configuration class passed to run be the same as the bootstrap class, this is the most convenient and typical choice. Chances are you won't need to change anything in the bootstrap class. For simple applications, you might find it convenient to configure one or two other components in the bootstrap class. But for most applications, you're better off creating a separate configuration class for anything that isn't auto-configured. You'll define several configuration classes throughout the course of this book, so stay tuned for details. Testing the application. Testing is an important part of software development. You can always test your project manually by building it and then running it from the command line like this. Or, because we're using Spring Boot, the Spring Boot Maven plugin makes it even easier, as shown next. But manual testing implies that there's a human involved and thus potential for human error and inconsistent testing. Automated tests are more consistent and repeatable. Recognizing this, the Spring initializer gives you a test class to get started. The following listing shows the baseline test class. There's not so much to be seen in Taco Cloud application tests. The one test method in the class is empty. Even so, this test class does perform an essential check to ensure that the Spring application context can be loaded successfully. If you make any changes that prevent the Spring application context from being created, this test fails, and you can react by fixing the problem. The @Spring Boot test annotation tells JUnit to bootstrap the test with Spring Boot capabilities. Just like @Spring Boot application, @Spring Boot test is a composite annotation, which is itself annotated with @extend_with Spring extension .class to add Spring testing capabilities to JUnit 5. For now, though, it's enough to think of this as the test class equivalent of calling Spring application.run in a main method. Over the course of this book, you'll see @Spring Boot test several times, and we'll uncover some of its power. Finally, there's the test method itself. Although @Spring Boot test is tasked with loading the Spring application context for the test, it won't have anything to do if there aren't any test methods. Even without any assertions or code of any kind, this empty test method will prompt the two annotations to do their job and load the Spring application context. If there are any problems in doing so, the test fails. To run this and any test classes from the command line, you can use the following Maven incantation. At this point, we've concluded our review of the code provided by the Spring initializer. You've seen some of the boilerplate foundation that you can use to develop a Spring application, but you still haven't written a single line of code. Now it's time to fire up your IDE, dust off your keyboard, and add some custom code to the Taco Cloud application. Section 1.3. Writing a Spring application. Because you're just getting started, we'll start off with a relatively small change to the Taco Cloud application, but one that will demonstrate a lot of Spring's goodness. It seems appropriate that, as you're just starting, the first feature you'll add to the Taco Cloud application is a home page. As you add the home page, you'll create the following two code artifacts: a controller class that handles requests for the home page, a view template that defines what the home page looks like. And because testing is important, you'll also write a simple test class to test the home page. But first things first, let's write that controller. Section 1.3.1 Handling Web Requests. Spring comes with a powerful web framework known as Spring MVC. At the center of Spring MVC is the concept of a controller, a class that handles requests and responds with information of some sort. In the case of a browser-facing application, a controller responds by optionally populating model data and passing the request on to a view to produce HTML that's returned to the browser. You're going to learn a lot about Spring MVC in Chapter 2. But for now, you'll write a simple controller class that handles requests for the root path, for example, /, and forwards those requests to the home page view without populating any model data. The following listing shows the simple controller class. As you can see, this class is annotated with @controller. On its own, @controller doesn't do much. Its primary purpose is to identify this class as a component for component scanning. Because home controller is annotated with @controller, Spring's component scanning automatically discovers it and creates an instance of home controller as a bean in the Spring application context. In fact, a handful of other annotations, including @component, @service, and @repository, serve a purpose similar to @controller. You could have just as effectively annotated home controller with any of those other annotations, and it would have still worked the same. The choice of @controller is, however, more descriptive of this component's role in the application. The home method is as simple as controller methods come. It's annotated with @get mapping to indicate that if an HTTP GET request is received for the root path /, then this method should handle that request. It does so by doing nothing more than returning a string value of home. This value is interpreted as the logical name of a view. How that view is implemented depends on a few factors, but because timeleaf is in your class path, you can define that template with timeleaf. Why timeleaf? You may be wondering why I chose timeleaf for a template engine. Why not JSP? Why not FreeMarker? Why not one of several other options? Put simply, I had to choose something, and I like timeleaf and generally prefer it over those other options. And even though JSP may seem like an obvious choice, there are some challenges to overcome when using JSP with Spring Boot. I didn't want to go down that rabbit hole in Chapter 1. Hang tight. We'll look at other template options, including JSP, in Chapter 2. The template name is derived from the logical view name by prefixing it with /templates/ and postfixing it with .html. The resulting path for the template is /templates/home.html. Therefore, you'll need to place the template in your project at /src/main/resources /templates/home.html. Let's create that template now.